Hello, this is Jade Xu from the University of Memphis. In this video, I'm going to discuss how to handle multi-level categorical variables when you are running regression analysis. In this data set, I have information about faculty salary, sex, years teaching in higher education institution, and years on current job. There's one variable that has three values. Race. That's a multi-level categorical variable. If you take a look, for race, we have three values. And there are 399 faculty members who are white, and 45 were African American, and 81 that are other racial minority. We cannot include multi-level categorical variable directly in regression analysis. What we need to do is to recode them into binary variables. If you have a variable that has three levels, we need to create two more variables. Each of them is dichotomous. If you have a categorical variable that has 5 values, that means you need to create 4 dichotomous variables to include in your regression analysis. Let's use the race variable as the example here. Okay, this is my plan. I have the 1 for white, 2 for black, and 3 for other minorities in my original race variable. So when I do my dummy coding, I'm going to use white as the baseline group. So I'm going to create 2 more variables. One is for black. So for faculty who are African American, they will have 1 for the variable that's black. And the other variable is for other racial minorities. So only those who are other racial minority will have a value of 1 in this variable. So I go to this place, transform. I'm going to recode into different variables. So for race, first, I'm going to create a variable that's called black, and decide my old and new values. So if the old value was 2, that's for black, the new value will be 1. Okay, then for all other racial groups, all other values, their value for this variable black will be 0. Okay, we continue and make the change. Okay, we need to do the same thing for the variable others. So go to transform, recode into a different variable. This time we're going to change the name to others, and you can call it other racial minorities. Okay, and now remember, originally they were coded as 3. So for the value that's 3, you code them into 1. Okay, and for all other values, for all other faculty members who are not racial minorities, other than black, you code into 0. Okay, and here we have 2 more variables. Let's just take a look. If we do the frequency table, we want to check if the number match with our original statistics. Okay, you can see that here we have 45 black faculty members, which is the same as the value in the original race variable. We have 81 other minorities, which is consistent with the original value in the race variable. We're good. So when I run the multiple regression, I would like to find out that whether there's difference in the income or in the salary of faculty of different racial groups after I controlling for measures of experience, seniority, and educational background. So I put my dependent variable, the salary here, and I control for their degree type, years teaching in higher education institution, and years on current job. Next, I'm going to put the two dichotomous variable of black and racial minority in my model. Remember, we can ask for descriptive statistics, linear narrative diagnostics. Okay, and let's take a look at the output. You can see that we have the descriptive information and the correlation between the variables, and our model is statistically significant because R-score is 0.28, which is significantly different from 0 according to the ANOVA table. And here is the coefficient table. If you remember, we use alpha equals 0.01 because we have a sample size of 525. I want to talk to you about those two variables. So remember, white is a baseline group. For this variable black, white is coded as 0, black coded as 1. So if you go up from 0 to 1, that means make a comparison between white and black. The predicted salary for black faculty member on average is about $6,608 higher than the average salary of white faculty members holding other variables constant. Means if they are same on those other three measures, and this is a difference in the average salary of black and white faculty members. In contrast, for the other racial minorities, still we have the white as the baseline, the 0 coding, and other minority as 1. And when you compare them holding other variables constant, the racial minority faculty members on average has a salary that's close to $9,000 lower than the salary of white faculty members. Keep in mind that these two dichotomous variables are recoded from the same variable that's called race. So they need to be entered together into the same model. When they are entered together, this comparison is between black and white. This comparison is between racial minority and white. If you only entered black with into the model, leaving out the racial minority, the comparison would be between black versus white and other minorities combined, because only black was coded as 1. White and racial minorities were coded as 0 together. The same deal for other racial minorities. If you only had this one in the regression model and left out black from the analysis, racial minority would be the group that's coded as 1, and white and black were both coded as 0 for this particular variable. So the comparison would be between other racial minorities versus white and black combined. If you had another 4 dichotomous variables, they are recoded from the same original categorical variable that has 5 values. The 4 dichotomous variables need to be entered into the model together for you to get the correct statistical output from the multiple regression analysis. Thank you for watching, and let me know if you have any questions.